Good morning, friends. I welcome you all to online C class, and today our topic is files. In this lecture, we are going to discuss few concepts about the files, and today's lecture we are going to cover the following topics. First, we are talking about the introduction of the files. We will discuss about how a file is used for storing the information, and then we are going to see what are the different types of files supported by the C language, and then we are going to discuss what operations can be performed on the files, and then we will see what are the parameters that we need to define a file, and then we are going to discuss about the functions supported by the C language library to perform operations on the files, and then we will discuss some important questions and assignments related to today's class. So let us start our discussion with the introduction to the files. Till now, we have used input and output functions to read data from the keyboard and to write the data to the monitor using standard input and output functions like printf, scanf, getchar, putchar, getas, puts. All these functions we have used, and all these functions are used to perform operations with default standard input and output devices. The default standard input device is keyboard. So for reading information from the keyboard, we can use scanf function or getchar function, or we can use gets function, and already these functions we have used in our programs. And similarly, to write information onto the screen, we can use default standard output related functions. They are like printf, putchar, and puts. These functions also we have used earlier in our C programs. But all these functions, they are dealing with keyboard and monitor. Since keyboard and monitor are called consoles, these functions are called console-oriented functions. And these console-oriented functions are used to read data from the keyboard and to write information to the keyboard. And this is fine as long as we have little amount of data to enter or little amount of information if you wish to give to your program as input during its execution. It is fine. But what about the situation where you are going to work with large volumes of data? Suppose you have written a program to sort a list of numbers. The list of numbers are enormous. Suppose assume that you need to sort 50,000 numbers or 70,000 numbers. And when you have that many large volumes of numbers to enter or to give as input to your program, is it possible for you during the execution of the program to type all that 50,000 or 70,000 numbers, integer values as input to the computer? Is it possible for us? It is highly difficult. So therefore, when we wanted to work with large volumes of data, console oriented input and output functions are not suitable. It is very difficult for us to enter the large volumes of data during the execution of the program. So like this, we are having some disadvantages with the console oriented functions when you are going to work with the large volumes of data. So what are the disadvantages if you see about the console oriented functions as far as large volumes of data is concerned? So one is, it is very difficult for the user to enter all that data through the keyboard during the execution of the program. That is the first difficult task. And not only that, it will take a lot of time to the user to enter all that information through the keyboard. And till you finish entering your data, your program cannot execute further. Your program execution is suspended till you complete entering of your data. So therefore, it is a time consuming process. And not only that, since large volumes of data is there, when the users are going on typing the data, the users may make some mistakes while entering the data. So the data may contain some errors when large volumes of data is being entered by the users. And even if you enter one value mistakenly as an input to your program, so your output will be wrong. So therefore, the data will be error and you have to take a lot of care while entering the data. So this is very difficult process when you are having large volumes of data. And not only that, the most important problem is when you are entering large volumes of data, you are taking a lot of time. And because of this time process, suppose suddenly, because of some reason, if the computer is shutting down, then what you have to do, whatever data you have entered up to that time, so that data you are going to lose. And sometimes the people may not have power backup facility. So suddenly if main power goes off, what happens? Whatever data you have entered up to that time, so all that data is automatically lost. And when the power comes back again, when you start your computer and execute your program, again there is a need for us to enter all that data right from the beginning. So it is a very difficult process. So how do we deal with such situations when we have large volumes of data? How do we enter that large volumes of data, or how do we give large volumes of data as input to the program during its execution? Or if the program wanted to display large amount of information on the screen, so it is not possible for us to keep all that data on the screen, because a screen can accommodate only little information. And when you want to display large amount of information on the screen, so since it doesn't fit on the screen, so what is the alternate solution you are going to have? So to deal with the situations, input and output situations where large volumes of data is there, normally we go with the files. Files are widely used to deal with large volumes of data. When you are having large volumes of data which you wish to give as input to your program, or if you are generating large volumes of data from a program as an output, so then we write that information to the file. The output generated by your program, instead of displaying on the screen, we will send it to the file. We will write that output to the file. And the user can see that output whenever he is free, because it is a large amount of output whenever the user finds free time. So he can open that particular file and he can go through the output of the program generated. Similarly, when a program wishes to take large volumes of information as the input, so we will keep all this information in the file. We ask the program to take input from the file instead of from the keyboard. Since data is there in the file, at any time your program can read information from the file. So reading information from a file is very much faster than entering all that data from the keyboard by the user. So therefore these are the techniques that we follow when we wanted to deal with large volumes of data. Then how a file is defined? What is file? What do you mean by file? A file means it is nothing but a place on the disk where a group of related data is stored. A file is a place on the disk where a group of related data items are stored. Means a file is nothing but some place on the secondary storage device where we are going to store the related information, a group of related information, a set of related information on the disk, and that group of related information is identified as a file on the disk. So files are largely used in the programs for storing user data and then to store records and for storing scientific related data and then for storing image related data, for storing audio related data, for storing video related data. So like this, for different purposes, files are widely used on the computer system for storing the information. So what type of files are there in C language? We are having different types of files. These files are classified into two types. All the available files are classified into two types as far as C language is concerned. So one is binary files and another one is the text files. Text files are also called ASCII files. What is binary file? The name itself is representing binary. Binary means by means two. Means binary files are used for storing information in the form of bits. Means if you see a binary file, if you open and if you see a binary file, the contents of binary file will be in the form of ones and zeros. You will find all information inside the binary file in the form of ones and zeros. All ones and zeros will be there inside the binary file. And since information is stored in the binary file in the form of ones and zeros, it cannot be understood by the user. User cannot understand binary language. But it is easy for the machine, computer, to understand what information is there in that file. Because the computers are familiar with the binary language. But users cannot understand this binary language. And then when you wanted to store these binary files on the secondary storage device, it is easy to store these files on the secondary storage device because secondary storage device like a hard disk, it also stores information in binary form. So therefore already the data is available in the binary form in the binary file. So therefore binary file directly it can be stored on the secondary storage device. They do not require any conversion. Binary files do not require any conversion because data is there in the binary form. Directly it can be stored on the hard disk because hard disk will also store information in the binary form. So directly binary file can be stored on the hard disk. So therefore, writing binary files to the hard disk is easy process and it is very fast. Why? Means conversion is not there. Similarly, when you wanted to read a binary file from the disk, you can easily read, you can fastly read the binary file from the disk because they do not require any conversion. Directly in whatever form the information is available on the disk, directly you can read it. And coming to the text files. Text file stores the information in the form of ASCII codes. And it may contains, the information contains alphabet, digits, punctuations, special characters. Alphabets means any combination of letters, capital letters or small letters from A to Z, and any combination of digits from 0 to 9 for representing the numbers. Punctuations of the English language can be used, and special characters can also be part of the information in the text files. Special characters means @ dollar, caret, opening parenthesis, closing parenthesis, opening brace, closing brace, etc., etc. So these are called special characters. A text file may contain the combination of all these characters, and all these characters are stored using ASCII codes. So because of this reason, text files are also called ASCII files. And ASCII, abbreviation of ASCII is known to you, American Standard Code for Information Interchange. So ASCII code means the American Standard Institute has assigned a unique integer value to each character. And this integer value is standard. It is fixed, that cannot be changed. And throughout the world, these values are fixed. And these values are used for communication, for transmitting the information from one place to another place over the communication networks. Example is the ASCII value of capital A is 65. It is fixed. The ASCII value of capital B is 66. It is also fixed. And the ASCII value of small a is 97. The ASCII value of small b is 98. The ASCII value of small c is 99. These values are fixed. Okay, so these values are called ASCII values, which are assigned by American Standard Institute. And these values are called American Standard Codes for Information Interchange. And the text files contains information in the form of English sentences. So therefore they can be easily read and understood by the user. And it is very difficult for the computer system to understand. The computer system doesn't know this language. Computers, they know only binary language. If the information is available in ones and zeros form, then only computer can understand that information. But in a text file contains information in the form of English sentences, so therefore it cannot be understood by the computer. Now, if you want to store text files onto the secondary storage device, it is very difficult process for us, because secondary storage device stores information in the form of binary. But the text file contains information in the form of alphabet, digits, punctuations, special characters. So how do you store? If you wanted to store a text file, first all that information, text information, whatever is there in the text file should be converted into a binary form. It should be converted into a binary form. So this conversion requires some time, and after the complete information of the text file is converted into the binary form, then the information is ready for storage on the secondary device. So this process will take some time. Means if you wanted to store a text file on a computer, text file first should be converted into a binary file, and in the form of binary file it is stored on the secondary storage device. So therefore, storing a text file onto a secondary storage device will take some time because the conversion is required from ASCII to binary. Conversion is required. And once the text file is stored on the secondary storage device, if you want to retrieve that file from the secondary storage device, if you want to read, again, first you have to read information in the binary form, and then that information to be converted into a textual information, and then it is displayed on the screen. So therefore, accessing text files from the secondary storage device will take little bit more time compared with accessing binary files, because binary files information is directly read in the binary form and it is displayed on the screen. No conversion is required. So accessing binary file is fast from the secondary storage device, but whereas text files, after reading from the secondary storage device, they need to be converted into a textual form and then they are to be displayed on the screen. So therefore it requires some conversion time. So therefore we can say that accessing text files will take little bit more time as compared with accessing binary files from a secondary storage device. And what are the examples for text files? We can quote all programming files which are created by the users. It may be a C language program file or C++ programming file or Java programming file or Python programming file or Pascal programming file. All these programming files, the programs written by the user in all high-level languages, are the best examples for the text files. So these programming files contains the statements almost like the English statements. So these statements are not understood by the machine, and these programming statements must be converted into a binary form if they want to be executed on the computer. So this process is being done using compilers. Compilers will convert your high-level language program into equivalent program in binary language or machine language. Then it gives that binary language program to the machine. Then machine executes your program in binary form. So these are the examples for text files. And what are the examples for binary files? The examples for binary files are all executable files. Executable files means after writing your program, you are converting your program into a machine language using compiler. So whatever file is generated by the compiler in machine language, so that file is called binary file, and it is called executable file, or it is called a runnable file. So all these executable files are best examples for binary files. Similarly, if you are having a file with audio data, the audio data in the file is stored in the binary form. So this audio file is called digital audio file because only information is available in the form of ones and zeros. So therefore it is called digital audio file. Similarly, the video file also contains information in the form of ones and zeros. So therefore it is an example for binary file. So audio files, video files, animation files, executable files, these are all examples for binary files. And in all these files, information is available in the binary form. And now, what operations can be performed on the files? C language supports some operations to be performed on the files. What are these operations? How these operations are performed on the files? And there are some files supported by there are some operations supported by the C language. Those operations can be performed on the files. First, naming a file. Naming a file. Every file must have some name. Like a person is having a name. A person is called with his name. A person is identified with his name. Similarly, every file should have a name. Every file in the computer system is identified with a name. So therefore, you have to assign some name to a file when you are creating a file newly. When you wanted to create a file, first you have to select a name to the file and you have to assign some name to the file, and then it is called naming the file. And the next operation is opening a file. You can open a file. Why we would like to open a file? So file is opened to perform certain operations on the file. What operations we can perform? A file is just like your notebook. In the notebook, you are going to write some information, means you are going to perform a write operation in your notebook, or sometimes you open the notebook to read the information that is present inside your notes, means you are performing a read operation on your notes. And sometimes you may add some data to your notebook. Okay, so it is called appending operation. Appending operation is also same as writing operation. Okay, appending means adding some data to the notebook is called appending. So we are using notebook for reading purpose, for writing purpose, for appending purpose. Similarly, when we wanted to perform some operation on the file, what we will do is we open the file to perform operations. Unless the file is opened, you cannot perform any operation on the file. Like that, can you read information from a closed file, closed notebook? No. Can you write information to a closed notebook? No. So if you wanted to perform a write operation in your notebook, or if you wanted to read information from your notebook, first you have to open that notebook. Similarly for the file, if you wanted to perform any operation on the file, so first we have to open that file. Once the file is opened, you can perform read operation on the file, or you can perform write operation on the file. You can add some data to the file. So adding data to the file is called appending operation. Okay, you can add data or text or information to the file. So that is called appending operation. Writing means writing information to the new file is called write operation. Appending means adding some data to the already existing file. It is called appending. Means writing information to the already existing file is called appending operation. And when all operations are being completed on the file, then we would like to close the file. Means after completing reading operation in your notebook, or after completing writing operation on your notebook, then definitely we will close our notebook and we will keep safely in Almara. So similarly, the same thing is done on the computer system. So after finishing the operation on the file, then we will close that file and we will keep it safely on our secondary storage device. A file is acting as a permanent storage device for the information. Once you write information to the file, and the file, once it is stored onto the secondary storage device, then your information is always preserved. At any point of time, you can open your file from the secondary storage device and you can read the content of your file. So information is preserved in the file. File is acting as a permanent storage for the information of the user. So to perform all these operations on the files, C language supports different varieties of functions from the C library. Okay, so by taking the help of these library functions in the C language, we can perform all these operations on the files. We are going to see what are the list of functions available in the C language from the C library to perform various operations on the files. So next, how do we perform all these operations on the files? Just now I told that we have different types of functions available from the C library to perform these operations. And these functions are classified into two categories. One is you can make use of low-level IO functions, or you can use high-level input-output functions. IO means input-output functions. Two types of functions are available in C language: low-level IO functions and high-level IO functions. And you can use any one of these functions to perform the operations which we have discussed just now to perform on the file. So low-level IO functions we can use, high-level IO functions. But to use low-level IO functions, we need some concepts of the operating systems. The concepts of operating systems you are going to study in your second year or third year level. So therefore, in second year or third year level, you are coming to know what are low-level IO functions and how these functions are used to perform operations on the files. And these low-level file IO functions makes use of Unix system calls. And what are system calls and how the system calls are being used in combination with the low-level file IO functions that you are going to study in your second year or third year level of BTech. So therefore, this discussion will be postponed. Now we will concentrate only on high-level IO functions. So high-level IO functions from C library we are going to use to perform operations on the files. Our concentration here is only on high-level functions. C language means C library. C language library supports both high-level functions and low-level functions. But here we are going to work with only high-level functions. Now, how to define a file to use them in the computer? So if you wanted to store information to a file to store on the secondary storage device, then we need to specify certain parameters about the file. So specifying certain parameters about the file is called defining a file. And what parameters we have to specify about a file? So if you wanted to define a file, you have to tell about three things about the file. And these three things are nothing but, first, what is the name of the file you wish to create? And then, what is the data structure that you are going to use to store the information to that particular file? And what is the purpose of opening that particular file? These three things we have to specify. And once you specify these three things about your file, it is nothing but defining that particular file. First, naming the file. Already we discussed that every file should have a name. Every file in the computer is identified with its name, like the person is having a name. Persons are identified with their names. Similarly, files are also identified with their names in the computer system. And what is the name? A name is nothing but it is a sequence of characters. Like we have assigned names to the variables, we have assigned names to the arrays, we have assigned names to the functions, like that. We have assigned names to the pointers, and all these names are called identifiers in the C language. Identifier means it is a name of a variable or a function or an array or a pointer. So it is called identifier. So similarly, we have to assign a name to a file. A name is nothing but it is a sequence of characters. But there are certain rules because it is a name. Name means identifier. So there are certain rules to be followed for selecting the names. What rules are there? We already discussed about the rules for identifiers. It should be any combination of alphabets, digits and underscore, and an identifier should start either with an alphabet or underscore but not with a digit, and special characters are not permitted as a part of the identifier, and spaces are not permitted, white space characters are not permitted as a part of identifiers, and an identifier can have a maximum of 8 characters, not more than that, because most compiler can identify an identifier with a maximum of 8 characters, but ASCII ANSI compilers supports identifiers with a maximum of up to 31 characters, but most compilers do not support up to 31 characters. So it is always better to select an identifier, means name, with a maximum of 8 characters. So like this, some rules we have specified for identifier. Same rules we have to use for selecting the names to the file. So this name to be assigned to the file when the file is newly created. Once the name is assigned to the file, we can refer that file using its name. We can identify that file using that name. Normally, a file name should be selected such that it should reflect the content present inside that particular file. Suppose if you are assigning a name to a notebook, how do you assign? Suppose that inside that notebook, if you are writing the information related to your science subject, what do you name that notes? Physics notes. Like that we will write. Suppose if you are writing the mathematics related information inside the notes, what is the name that you are assigning to that notebook? So we assign a name, mathematics notebook. Means once you see the name on that notebook that it is mathematics, then immediately we can conclude that inside that notebook all mathematics related information is available. And if you see any notebook with a name physics, immediately you can identify that all information related to physics is available inside that notes. Similarly, when you are assigning a name to a file, the name should reflect the contents present inside that file. So like that we have to select the names to the files. Meaningful names to be selected for the files. And some people will select the file names as their names, like Abhinav 1.c, Abhinav 2.c. So what is a file name should not be like this. Okay, so the file name should be meaningful and it should reflect the contents that is present inside that particular file. And usually file name contains 2 parts. First you are having a meaningful name followed by a extension, followed by an extension. And this extension is optional. And both file name and the extension are separated by a dot. Okay. So some examples for the file names are test.txt. Now txt is an extension. Test is the name of the file. And test and txt both are separated by a dot here. So that is the name. Test.txt. Similarly, another file name, data.dat. Dat represent that dat is the extension of the file. The extension will tell what type of information is there inside that file. So means that .dat represent that it is a data file. Means some data is present inside the file data. Txt means text. Means some text is present inside the test file. Similarly, it is Guardian. So Guardian.jpg. JPG is an extension. This extension JPG tells that it is an image. JPG image means it is a photograph. So some photo related information is available inside guardian.file. So like that you can select some meaningful names, and these extensions are optional. If extension is there, both extension and the meaningful file name should be separated by a dot. So like that a file name contains two parts. So this is about the name of the file. And then data structure. Second parameter that we have to specify about the file is data structure. The data structure tells what type of structure you are using for storing information in the file. So we have to use a meaningful structure to store information inside the file. And this meaningful structure is already developed by the developer of C language, Dennis Ritchie, and named that data structure as a file data structure. Because this structure is used to store information inside the file. So therefore, he named that structure as a file structure. So when we wanted to work with files and when we wanted to store information to the file, so we use a structure called file structure. And this file structure is already defined by Dennis Ritchie and kept as a part of standard input-output library of the C. The data structure file is already defined and kept as a part of C library stdio.h. And this data structure, file data structure, we use to store information to the file. And similarly, after storing information to the file, if you wanted to read information from that file, same data structure we have to use to read information from the file. So usually we use pointers which are defined to point out the data structures of type file. So we use those pointers, means we are going to use a pointer which is of type file data structure type. These pointers we use to perform operations on the files, means to write information to the file and to read information to the file. We are going to use pointers which are of type file data structure. So through the pointers of type file data structure, we perform all read operations or write operations on the files. So this is the data structure we use. File data structure we use. And this data structure name is file, and it is always represented using capital letters. F-I-L-E, file. File means it is a data structure that is used to write information to the file or to read information from the file. Next, the third parameter that we have to specify about the file is purpose. The purpose will tells the reason for opening a file. We have already discussed opening a file. Why we would like to open a file? File is opened to perform either a read operation or write operation or appending operation on the file. If you wanted to read information from the file, first you have to open a file. If you wanted to write information to the file, you have to first open the file. Then only you can write information to the file. If you wanted to append, means add some data to the file, then you have to open the file first. And then you can add some data to the file. So to perform a new operation on the file, first you have to open that file. The purpose will tell why you are opening that file. You have to tell the purpose. Means for reading operation you are opening the file, or to perform writing operation you are opening the file, or to perform appending operation you are opening the file. That purpose, that use you have to tell. So it is called purpose of the opening the file. So to perform all these operations, naming a file and data structure and then purpose, to tell the purpose of opening a file, all this can be specified using C library functions. And C library functions can be used to tell these three informations about the file. Once you specify about these three informations related to the file, three parameters related to the file, we can say that the file has been defined. Now, what functions are supported by the C language to perform operations on the file? So C library supports many high-level functions. And these functions, high-level functions supported by the C language, will slightly differ from compiler to compiler. Because in the market we have different varieties of C compilers developed by different companies. So therefore, some of the compiler supports more number of high-level functions. Some of the compiler supports less number of high-level functions, and some compilers supports average number of high-level functions. But here I have given the list of some high-level functions supported by almost all C compilers. And when you are working with a particular C language compiler, you can refer the library of that C language compiler to know what type of high-level functions are supported by that compiler to perform operations on the files. But whatever list I have given here, so these lists are supported, these functions are supported by almost all C language compilers. So what are the list of high-level functions? First, it is a fopen function. So this fopen function, for what purpose we use? fopen function can be used to create a new file in the computer system, or you can use to open an existing file. If a file is already existing in the computer, if you wanted to open that file, then we can use fopen function. That is the purpose. fopen function is used to create a new file or to open an existing file in the computer. And fclose function. Fclose function is used to close the file once all operations are done on the file. Once you perform all operations on the file, you can close that file. To close the file, we use fclose function. That is the purpose of fclose function. getC function. getC function is very similar to getChar function. We have used getChar function to read one character at a time from the keyboard. Similarly, getC function is used to read one character at a time from the specified file. getC function is used to read one character at a time from a specified file. Then putC function. putC function is very similar to putchar function. putchar function we have used to write one character at a time to the screen. Similarly, we can use putC function here to write one character at a time to a specified file. And then getW function. getW is very similar to getC function. getW and putW, they are used to work with only integer values. getW, as the name represents, it is used to read one integer at a time from the file. One integer value you can read at a time from a specified file. And putW we can use to write one integer value at a time to a specified file. Means getW is very similar to getC. putW is very similar to putC. putC is used for writing one character at a time. putW is used to write one integer value at a time to the specified file. getC is used for reading one character at a time from the file. getW is used for reading one integer value at a time from the file. And then we are having fscanf function. It is very similar to the scanf function. Scanf function we have used to read a formatted data, means a data of different types like integer values and double values and long double values, character values. These are called formatted data. So this formatted data we have read using scanf function from the keyboard. Similarly, fscanf function is used to read formatted data from the file. fprintf. It is very similar to the printf. Printf function we have used to write formatted data onto the screen. But fprintf function is used to write formatted data to a specified file. So fscanf is similar to the scanf function. Fprintf is similar to the printf function. And the FEOF function. FEOF stands for file end of file. And this function is used to identify whether we have reached to the end of the file or not. When you are performing a read operation on the file, you want to know whether you have reached the end of the file or not. Because once you reach the end of the file means no data is available afterwards in the file. After that point, no data is available in the file. Then we say that end of the file is reached. It means all data, whatever is there in the file has been read by you. So therefore, you need to identify whether you have reached the end of the file or not. So to identify whether you have reached the end of the file or not, we use FEOF function. And ferror function is used to know whether any error has been taken place while performing the operation on the file up to that point. You are going on performing operation on the file, and at some point of time you wanted to check whether any error has been generated during this operation on the file or not. So then you can use ferror function to know whether any error has generated while you have performed this operation on the file up to that point. So for that purpose we can use ferror function. Fseek function. Fseek function is used to locate the file pointer at a desired place in the file. So we are going to discuss how to keep the file pointer at a desired place within the file. So for that purpose we can use fseek function. And then ftell function. Ftell function is used to know the position of the file pointer in the file from the beginning of the file. So ftell function gives the position of the file pointer from the beginning of the file, at what position it is there in the file from the beginning of the file. So that position is given by the ftell function. We are going to use these functions in our programs. Rewind function. Rewind function. So as the name represents, rewind means keeping to the beginning. So rewind function is used to keep the file pointer to the beginning of the file at whatever location it is in the file. Once you use rewind function, it takes that file pointer and keeps it in beginning of the file. For that purpose we use rewind function. And all these functions, as I told, they are supported by many compilers because these are the functions that are taken from the ANSYS C compiler. So whatever functions are there in the ANSYS C compiler, so all these functions are supported by all other companies, developed by different companies. And the compilers developed by other companies, they are also supports other high-level functions. Apart from these functions, they support few more additional functions. So therefore, I am suggesting you to refer the library of that particular C language compiler to know what functions are supported by that compiler to perform operations on the files. So this is about the functions supported by the C language. Now we are about to close today's class, and before we are closing, and what are the important questions related to the topics that we have covered in this class, and what are the assignment questions. So assignment questions and important questions are same because only important questions will be given as assignment to you. So the first assignment question is, what is file? You have to define file. A file is nothing but it is a place on the disk where a group of related data is stored. That is the definition of the file. That definition you have to write. And then differentiate between binary files and text files. we have discussed the differences between binary file and text file. So same differences you have to write. Means this question was asked many times as a short answer question. 3 marks question. It was asked many times as 3 marks question in the end semester examinations. So therefore you concentrate on this question. And then second important question is list different types of functions with their use or purpose which are used to perform operations on the file. Just now we have discussed what are the different types of functions supported by the C language. I have given a list of functions and their use, for what purpose we are using these functions in the C language to perform operations on the files. So clearly you have to write all these list of functions carefully and you have to explain about what is their use and how they are used to perform operations on the files. So this you have to write carefully and you should aware of all these functions. And this was also asked as a short answer question in the end semester examination. So therefore you have to concentrate on this. And friends, in C language, files concept is very small concept and it is also easy to learn. So therefore, if you concentrate a little bit on the files, you can easily learn these concepts. And not only that, and this concept is also very, very important for scoring marks in the end semester examinations. In every end semester examination, definitely you are getting 15 marks questions in the examination. Since the topic is very easy, it only requires a little bit concentration. So if you concentrately read files, it is easy to you to score 15 marks out of 15 in the end semester examination. And these file concepts are also widely used in the programs to store information permanently in the computer system. Till now, whatever input you are giving to your program during its execution and whatever output is displayed by our program during its execution, so it is there only temporarily for that period of time. And afterwards, if you want to see what input you have given to your program and what output is being generated by your program, it is not available. But if you store the information that you wish to give as input to your program in a file, and through the file if you are giving input to your program, so it is there permanently in your computer. Afterwards, you can check for that program what input you have given. Similarly, when the program is generating output, if you write that output to a file, then that output you can see at any time, because once the output is written to a file, so that output is stored permanently in the computer system. So at any point of time, at any time, you can open that file and you can see what output is generated by your program, what input you have given, and what output is generated by that program. You can easily see and you can analyze the output. So that is the great advantage of the files. Files are used to permanently store the information to the hard disk. So your information is preserved safely if you are storing information in the file. So this is about today's class about the files. So in the next class, we are going to discuss the functions which we have listed out. What is the prototype of that function and how these functions are being used to perform varieties of operations on the files. We are going to discuss these functions one by one with their syntax and with their use and how they are employed on the files to perform operations. One by one we are going to discuss clearly. Okay, so in today's class, If you are having any doubts, you can call me on my mobile number 9848 919656, and you can ask me the doubts. I am ready to help you. I am here to clarify your doubts. And I thank all of you for patiently listening to this video lecture. Thank you all.